Welcome to this 88K model railroad video, and it's been a while since I posted, and I've been tied up with work, so things have kind of settled down, and I want to catch up on a lot of my videos and projects. This is going to be the first one that I tackle. It is the Woodland Scenic Ridge, and it's my custom build, so I've got a lot of modifications to it versus the kit that you can get from Woodland Scenics. What I want to do is to add a siding inside of the mountain. I want to be able to dispatch trains to and from the siding in the mountain to give it a little more depth. That's going to require me to modify or work with the Atlas switch because that's what I've got configured for this particular layout. I used the NCE QSnap modules, and I was going to just buy another module. It was $80 some. I only needed 2 additional switches, so I kind of thought that would be overkill or waste of money. Because we built controller modules for the Kato switches, I thought we should just build the same for the Atlas switches. The circuitry that we're going to use is the Capacitor Discharge circuits. That uses a capacitor to throw the switch, then discharge the capacitor to throw the switch back. We're going to create and make our own circuit. The CDU uses a manual switch. What we're going to do is to add a solid state switch so we can control it through Rockwell. So with all the components, we're going to build it on a breadboard. We're going to test it out. Once we see that it works, then we're going to build the board itself. In this case, we're going to have 3 units or 3 switches per module. So we'll have 2 modules. And once we do that, then we'll do the install and then do the final test. So with that said, let's get started. So let's look at how the capacitor discharge works. You can see that there is a manual switch here, SW, and whenever you throw the switch, it will cause the capacitor to charge. The 14 volts is then applied to the capacitor. The capacitor will then charge and throw the switch in coil 1. Once that occurs, it's the capacitor is discharged, the capacitor is charged, then the circuit is then opened. And in this case, we would have a momentary switch. It will be in the center position. When we want to throw the switch, then we would we would throw SW1 to the closed position, and then the diodes, which allows the current to flow in one direction depending on where the anode is connected or the cathode is connected. The coil 2 will then discharge from the capacitor and throw the switch. Then the switch ends up going back in the center position. What we need to do now is to set up the circuitry to support the 2 coils, but we're going to set up or configure a solid state switch. So let's look at that circuitry. Here we have the solid state circuitry. On the left hand side, you can see the components, the MOSFET, the BJT, the resistors, the 14 volts. In this case, we're going to use 14 volts to throw the switches. And the ESP32, which is a microcontroller that's going to throw or control the switch itself via the CDU. The way that the circuit works in the with the MOSFET, this is a dual channel MOSFET. It has an N channel and a P channel MOSFET. We need the P-channel MOSFET because what we're going to do is send voltage to the capacitor, the 14 volts. So that requires us to use a P-channel. The N-channel is going to handle the discharge of the capacitor. So the N channel is then going to connect or route the capacitor to ground, which is going to throw the switch in the other direction. We're going to use the microcontroller to actuate the gate, and the gate is what controls or actuates the circuitry in the MOSFET. So we'll have one for the throw and then the other for the close, which is the discharge. So that's why we see two. Now the way I have it configured, this is just a single channel. And remember I said we're going to put 3 of the switch or CDUs onto one board, and we're going to have 2 boards to give us the 6 switches. So that gives you an idea. I've got the list, the parts list here. You can pause the video to look at everything. I've got it wired and color coded. So if you want to build this circuit yourself, you can follow along and do, make the same connections. First on a breadboard, then after the breadboard, you can then create your own board. That's what I did. So let's look at the breadboard. Okay, so before we go to the breadboard, we need to look at the MOSFETs, because the way the MOSFET operates is a little bit confusing, especially between the N-channel MOSFET and the P-channel MOSFET. As you can see here on the P-channel MOSFET, we have to use a BJT, a bipolar junction transistor, and in this case an NPN. And the reason why we have to do that is the MOSFET makes a comparison between what's on the source and what's on the gate. So let's look at the characteristics of the P-channel MOSFET. When you have the 14 volts that's on VCC, then the MOSFET is looking at the voltage, in this case coming from the GPIO pin, which is going to be a -3. And in order for it to conduct, it has to see a negative voltage applied to the gate in respect to the source. So when you see the -3 volts and the -14 volts, it sees a -11, which will cause it to actuate or cause it to conduct. That is important, that you match up your VCC that you're going to use with what the GPIO pin is going to do and what the gate threshold voltage is on the design of the circuit. In this case, we're using the MOSFET that works in this particular configuration. If we go back to the N channel, you'll see that it's flipped because we have the drain that's the VCC, but in this case you have to have a positive voltage to the gate in respect to the source. So here the source is ground, so when we apply 3 volts, it's going to see that that's positive and it's going to conduct. So that's the difference between the two. So when you set up the circuitry, if you're not careful, you can put the wrong voltage on the drain or source, and that will cause your circuit not to work. So you have to pay attention to that particular issue. But if you follow everything, the parts list and everything that I have, you'll see that it works. So now let's look at the breadboard. Okay, we have the breadboard here, and everything's laid out similar to the schematic. On the right hand side, you've got the switches that goes to the capacitor to the MOSFET. MOSFET has a BJT, and then to the left, the 15K resistors and the 270K resistors. if you zoom in on the image, you can see the 15K resistors are here. This is the BJT with the base collector and emitter, and everything is colored, coordinated with the schematic. So you should be able to replicate this. I have a buck converter with an 18 volts input, and the 18 volt input is supplying the buck converter is dropping the voltage down to 14 volts, which is what I want to use because I have that on my on the existing layout. That's the voltage that's running on the for the accessories. The ESP32, I've got the WROVER using. In this one, you have to omit a couple of the IOs. I think 3 of the IOs you have to admit. This has a total of 16, so I need 12 in order to actuate 6 switches. The switch here, you can see it's melted. I wasn't paying attention. I threw the switch and it heated up and it melted the plastic, but the switch is still operational. So it's a good thing that's here because it just gives you a little reminder to watch out for the coils and what they can do if you leave the switch on. And I had it set up for just a manual switch, and that's where that's why it occurred when I was doing the manual testing. So that should give you everything you need to create your own board. You can once again do or set up the breadboard. Do that first. That's your best way, and then that way you can see how everything works and then build your board. And that's what we're going to look at next. Here's a module built, and as usual I use the pref board and the boards that what they call the breakout boards, and I populate the chip onto the breakout boards and then wire them on the back, just like we did in the other controllers. This allows you to see the configuration, all the components, and then how they lined up here. The red little jumpers is where I just kind of put power distributions where I can wire wrap to those locations and kind of fan things out. You can see here at the bottom right hand corner I've got the jumper pins, and then I just solder bridged the wire going across and then connected one of the negative leads or one of the signal leads to that, and that way I could fan out to 5 or 6 different positions. So this is the board. It's completed. I tested the board, and I'm not going to waste time filming and showing the testing or the operations of that. So with that, we've got the board completed. It's functional, and we're ready to install it onto the layout, and that's going to be our next video. So as usual, like, subscribe, and we'll talk to you guys later.